Good afternoon, everyone. My name is Sam Schwartz, and I'm with ACG. Thank you so much for joining us for our ongoing Essential Commissioning webinar series. Every month, we're touching a new facet of the commissioning process, and today we're going to talk a little bit about BIM. Special thanks to CxAlloy for sponsoring this particular session. I'm going to cover a few notes before we get started. Presenter Darren will be holding any questions until the end of the presentation, but we do encourage you to submit them at any time using that Q&A button that you see at the bottom of your screen. If you happen to be experiencing any technical problems during the webinar, please use the chat function to inform the panelists and we will assist you. This presentation is being recorded and will be available for viewing within 1 week. And then finally, in terms of continuing education credit, everyone in attendance for the full webinar will receive a certificate of attendance sent to their email. However, if you are certified CXA or EMP, expect for your CEUs from this series to be automatically uploaded to your respective portals after the last webinar in December. So today's webinar, as I mentioned, is on BIM and what commissioning providers need to know. And Darren Draper is with us today. He has 16 years of experience in the building services industry and serves as a commissioning agent on a wide range of facilities, including university buildings, research laboratories, healthcare facilities, and data centers. And for those of you that are not aware, he also takes part in ACG leadership. He serves as a board director and is also an instructor for the CxA workshop. So I'm going to hand it off to Darren now, who's going to talk a little bit about BIM and what commissioning providers need to know. Darren?
Hey, Sam, thank you. Good afternoon, everybody. I'm going to share my screen now. Thank you for the introduction. All right, well, let's get started today. So, what do we want to know about BIM as commissioning providers? And so I'll start a little bit with what building information modeling is, just to make sure we cover the high points of it. Hopefully, it's familiar to most of you, but we'll skim through it and then dig into what the advantages are of the commissioning agent being involved, at least in some form, in the BIM process. We'll look at some examples of what things are helpful to be looking for if we're going to participate in the BIM process, and then get a feel for what the value add is for commissioning agent participation in that process, particularly to our building owners that we're working for. So what is building information modeling? It is defined by Autodesk as a holistic process of creating and managing information for a built asset. It's three-dimensional, often more dimensional than that. It can be used for scheduling, sequencing of activities. There's almost no limits to the tool. It includes physical and functional characteristics, including metadata. It's a multidiscipline collaboration tool, which from my perspective is probably the biggest benefit it provides. And the growth and use of it is pretty astounding, even just over a 10-year period, that up from 13% in 2011 to around 73, three-quarters of construction professionals are using BIM in 2020. So that's a big number, and I think it'll become pretty much the norm on all projects of consequence, if it isn't already. And it can be seen in both vertical and horizontal projects, full-scale developments. For a lot of us, we're dealing with it on individual buildings or phases of buildings. And it's generally used as a tool for risk mitigation and by architects, engineering firms, contractors in particular, doing things like clash detection, coordination of between trades as well. And so, yeah, very powerful tool. So where does commissioning fit in? Certainly what we're going to focus on. But we, as a commissioning provider, we're often asked to look at things like shop drawings, and generally speaking, contractors are actually going to develop their shop drawings out of BIM models where they're deploying the BIM process. So we're usually seeing that for final coordination. It's done by floor, often by segment, section, a phase of a building. And then the process starts at, is defined with a level 0 as conceptual for what BIM modeling is, up through level 3, which is fully integrated shared model. And this is where, at our firm, we're interacting with it the most, is other entities, contractors, architects, engineers are using it, but they are collaborating within a shared BIM model and working together collaboratively to build the building before we build it. A couple other things that are important is that from our perspective, we often see that the information, the metadata, which could be extremely valuable, is still kind of being neglected. We have seen some uptick in adoption of migrating BIM model data to CMMS. I still think there's pretty strong opportunities for that, just given that the data is already there. We haven't seen as much adoption yet as I'd expect to see, but I do think that's coming. As client sophistication improves, more people are involved in the BIM process, and the expectations for that migration are more clearly defined. But then the other thing that's important about what's in the BIM model that is relevant to us, pretty much everything today can be modeled that's going into a building. We typically do not see electrical conduit less than 3/4 of an inch in size modeled, though we do see things called no-fly zones. We'll talk a little bit about that later, that impact or address bundled conduit runs. And then for the most part, we still see a lag in the low voltage trades being modeled, both conduit and non-conduit components like access control, security, AV, all this low voltage wiring is generally not in there. And we do see some plumbing lines not included when they're particularly small, lab gases and things like that. But down to pipe hangers, we are seeing in BIM models these days, and that's extremely helpful in coordination in advance of construction. Okay, so that's an overview of the BIM process at a very high level. But really, the point today is to talk about why is that relevant to the commissioning agent. So for a typical commissioning scope, if we're lucky, we're brought in early enough to be involved in things like design reviews, providing insight at one or more iterations of the design phase, looking at submittals concurrent with the design team, including shop drawings. And we're conducting site visits to review, at some level, to review installation for access, maintenance, things like that. But generally speaking, we are not seeing specific requests, or it's not typical to see requests to participate in the BIM process, at least not in any consequential way. And that's reasonable. There's no particular reason it has to be the case that the commissioning agent is involved in the BIM process. But I'll talk about, kind of why I think it makes sense for commissioning agents to get involved, if possible, if the scope can support it and the project is large enough, and will utilize BIM. So we do know, just in general, certainly as commissioning agents, we advocate earlier involvement in the project as early as is practical, starting with OPR development in the concept design stage or in the SD stage, where we're facilitating that activity. Early stage design reviews and doing multiple iterations of that to provide our feedback, insight from our lessons learned over the years, best practices for design and controls, things of that nature. And we're producing commissioning specifications that lay out expectations for commissioning process during construction. And then earlier involvement in construction phase is generally true as well. We want to give our feedback on the construction schedule in the earliest stages, ensure the commissioning on the back end, functional performance testing has been included in the schedule, commissioning related activities like test and balance, controls, equipment startup, energization, building drying, that all of those have been fully addressed in this schedule, and make it clear, provide clear feedback on how that impacts our commissioning effort, reviewing submittals, as I mentioned, and then just overall coordination of the commissioning activities, getting that established early in the process. So the general point being that the earlier involvement we can provide, the more potential for savings or cost avoidance there really is. So the end process and getting some level of involvement in that allows us to push some scope to the left in the schedule in things like first looks in what the installation condition is going to look like. So this graphic here, briefly before I move on, I just wanted to kind of point out, a big chunk of our undertaking does occur from construction start on, and even a bigger chunk of that, probably at least half of our scope and fee in the construction phase is really the last few weeks or months of construction with our functional testing activities. But again, when we do so much of our work that far back in the construction of the project, there is missed opportunities if we don't do things like design reviews or site visits. And so, well, what's the point then of being involved in the BIM process, right? So what's some other things we normally run into? We're generally excluded from early construction coordination activities by accident or on purpose, usually probably by accident, or perhaps if we're just not engaged at all. An incomplete schedule, something that's pretty high levels that doesn't drill down into the commissioning process at all. I make a joke that test and balance in a construction project on the back end of construction is always 15 days, regardless of size and scale. And so, we do see incomplete schedules quite a bit. And then construction sequencing, how that's going to go, how commissioning layers into that, what the phases are of installation, startup, and checkout may have minor or major impacts on our commissioning process at the end of construction. So the thinking is that, well, what if we've got these other things we want to do early, so why not take advantage of the BIM process and include some BIM meetings in our scope, participation in BIM fly-throughs or some interaction during the BIM coordination meetings with the subs and the general contractors. What can we do to bring some value to that process? So a way you could do that is if the client's not asking for that service, think about requesting it or simply including it in your proposed scope. There's a number of different ways you could do this, but it starts by just deciding that if the project justifies it, if BIM will be deployed by the architect and engineer and or the contracting team, go ahead and include some scope. And then the idea is that you would set up with the client, the owner, to conduct fly-throughs of the model at the appropriate time with the GC and their subs participating. So, this can work as a virtual meeting. Like anything else, meetings are generally more productive in person, but getting a lot of people together for something like a BIM coordination meeting, including all the subs, the folks responsible for modeling on the subs end, the general contractor, the commissioning agent, and then folks from the owner's team, can be difficult to do and get coordinated in person. So certainly perfectly fine to do virtually if you can't make it happen in person. The idea is that you get it set up and you execute it. We have typically seen these executed by floor. So it's really just about how the contractor is sequencing their work. So if they're releasing a floor at a time on shop drawings, that means they're modeling in advance of that by floor generally. And so, a 4-story building might mean, with a penthouse, might mean 4 fly-throughs for the floors, a fly-through for the penthouse might be an hour or 2 of time. So we're not talking about massive involvement or an abundance of time that's necessary to provide some input. One thing I will say that is generally going to be best from our experience is to have the AE and the architect and engineer involved with the primary characters to provide real-time insight or feedback as part of the Q&A process. There's ability to have that in the midst of a fly-through like this, so that if a sub is running into a coordination problem or we're trying to figure out maintenance access for a particular piece of equipment, all the appropriate parties are on that meeting or involved in that meeting to work through those details. All right, so given that it's a pre-con activity, one big thing that this does for us by getting involved in pre-construction, or at least in very early stage, is it establishes the point in the commissioning process, and more so than just the owner announcing commissioning will be involved. Often we're getting started with some submittal reviews, but then we might be waiting to the back end of that and MEP rough end before we get too heavily engaged on site. And so this pushes the importance of commissioning up in the schedule a bit, reinforces it. And just by doing so establishes some stickiness. You start to meet the right people, you're interacting with lead personnel from the contractor and their subs. And so this is extremely productive. You might even be asked to weigh in on a BIM execution plan that's produced by the contractor. We have some projects these days where we're actually asked to sign it, not in an official capacity, but to indicate that we reviewed it and we're going to play a role in reviewing the BIM model with the GC and their subs. It also, again, pushes scope forward and allowing us to stay engaged directly with our client. There can often be a gap between the late design phase and the real heavy lifting of site visits and whatnot on construction site visits for commissioning agents. So keeping that connection there is positive, making sure they know what we're doing, we're involved in it. And then it exposes the GC, maybe the most important thing, both the GC and the subs, to some direct operations and maintenance considerations that, when considered in the BIM process, can carry forward into the install, not just by addressing things like maintainability by modeling appropriately, but just getting them thinking about it, knowing that what particular types of expectations are being laid out by the client and their operations and maintenance team. Every O&M team, every client and their O&M team have slightly different expectations. Certainly most all of them want as much ability to maintain equipment as possible, but they all have nuanced differences about how they go about it. And so some of those things come out in BIM coordination exercises, BIM fly-throughs, by getting the client involved, getting someone from their operations and maintenance team involved, and it really can help empower them, right? So before I go further, I do want to throw up a poll, Simran, if you don't mind, and ask a question to the group. I promise I won't do this more than once. And basically it's asked, as the CxA, have you been asked by the client to participate in the BIM process to now on recent projects going back there? Just a yes or no on that would be great. And I'll give everyone just a minute to answer. Okay. So as that starts to come in, I'll continue on and we'll take a look at that. Oh, here we go. So, okay, so this is not terribly out of line with what I was expecting. I figured it was maybe a quarter of everyone had done that. So we're about that. I really appreciate the feedback. It's a lot of the feedback as well. So only 20% of the group has been asked to participate in the BIM process by the client. So that's great information right there. Thank you. So, so continuing on, what else does this allow? I mean, it allows the commissioning agent. We think we know pretty well what we're doing, and we have certainly important feedback to bring. It's the same reason we like to do design reviews. We can demonstrate additional value to the owner in this process by simply participating in a BIM fly-through, getting the ability to access the model remotely and maybe log into it, look at it, fly through it on our own, or at least certainly participate in these fly-throughs, demonstrates direct value to the client when we provide constructive input. And conversations that move forward that too often occur later in commissioning. So, I mean, the easiest example is when we're walking a site, we look up, or we're looking at something for access, and based on install progress, we see something's clearly out of whack. We're not going to be able to maintain XYZ piece of equipment, air handling unit, pump, terminal unit, reheat coil, whatever it may be. And if we had perhaps participated in the BIM process in some form, that would have been pushed forward. We would have avoided that happening before it was even installed. We're not going to avoid all issues like that just by participating in the BIM process. I think anyone should be under the impression that we will. But again, we move things forward in the schedule. We provide feedback before things are built, the better off the project will be. Certainly, it's easy to say in design reviews where we see problems with maintainability or access, but really where the biggest impact that can be is in the BIM process, because they're building off of that. They're actually laying it out. They're going to build off of that. They're going to do shop drawings, fab off of that. And so generally what's in that BIM model is more or less what we should expect to see in the field. And we haven't directly done this at our firm, but you could theoretically reduce site visits by doing so. And maybe that's of value to a client who doesn't want to pay for 10, 12, X number of site visits across the country, or to whatever distance where they're paying for you to get there. And you could reduce a few by participating in the BIM process, because you're going to see some of the same things you would see, maybe even see them better, to be honest, in the BIM process than you would see them in the field, because of the ability to be in 3 dimensions all the way. And I think that we all know we're walking around on sites, even if there's a ladder around that we could hop up on, we still can't see as much as you can see when you can fly around in a BIM model. Not to mention that installation progress is a snapshot in time, and the BIM model is what it would look like when it's done. Okay. Okay, so that's some of the things I would say are advantages. So what are we looking for, right? What value are we bringing? What are the things we're going to suggest? So things that are good to come out like this one at the start of the BIM process are really establishing expectations for how trades are being coordinated, and that actually can go back into the design phase a bit. But certainly it's not too late to talk about it in the BIM process. It's just the overall MEP overhead coordination, so stacking of trades in the ceiling space. And that's an important thing to think about. So as you look at this snapshot of a cut through in a BIM model, where you see terminal unit with reheat, you see exhaust duct running perpendicular to that. You can see, just a litany of hangers for piping and duct. You see conduit running there in the light blue. You see a big conduit bundle in the light blue in the background there as well. Plumbing, fire protection, all these things have to be coordinated. And why is that important for a commissioning agent? It's not that it'll all fit so much, though that is important. It's that we can get back to the things we need to get back to. So terminal unit with reheat, that requires maintenance. A plumbing line with an isolation valve in it requires some maintenance. Conduit at a pull box requires the ability to access, but the conduit itself generally doesn't. Kind of similar with the fire protection mains. You hope to not have to get back to those too terribly often. So trying to lay out the expectations for that ideally with the design team early on in their design, but certainly in the BIM coordination process is important. So we're wanting to prioritize those components that require access, and that can really go back all the way into the layout of MEP components as they lay out in vertical shafts and move into the floors that impact overall overhead access. So you see some examples here from some design documents where you see a very busy vertical shaft for ductwork and some piping. And what really the implications are of that is the way that we're going to come out of the shafts, and then how those are stacked inside the plenum space overhead on each floor. And so that top version there is actually a prioritization matrix or a prioritization section view, showing where things need to be that require maintenance and things that do not, to try to make the process easier for BIM coordination for the general contractor and their subs, right? So the general idea, is to put things as low as possible that require the most maintenance, as close to the ceiling as possible, so that you can get on a ladder, an O&M person can get on a ladder, get to that piece of equipment or that device, and do the maintenance activity they need to do. Isolate a plumbing line, get to a controller on a terminal unit, pop a lighting fixture out to replace it, to change out a ballast, things that are critical to maintenance activities. And I think we all know that if it's not in a place where it can be maintained, it probably won't be maintained, and that is detrimental to long-term operation of the building. So more on in terms of maintenance access, you can just see here, terminal unit there with reheat at the bottom left. And so something that we really emphasize going into the BIM process where we're going to be involved is that the contractors need to model the maintenance access. And generally speaking, they try to do that. The code required clearances 2 to 3 feet, depending on what it is. So call it 3 feet, and that's out from the device. So in this case, you're looking at a terminal unit with a reheat. So that controller needs, call it 3 feet of clearance in the horizontal. But that doesn't help you when you've got to get up to it. So you could have it clear if you model that maintenance clearance outward, but we expect to see that it's modeled in the vertical as well. So take that entire maintenance clearance down. You still have to get on a ladder to get up there to it, to get up to the controller, the reheat valve actuator, the circuit setters. All of those things require the ability to access. And so if we don't model that vertical clearance, what we will often find is there could be something below that in the plenum space, but usually that's avoided. It's things that go down below the ceiling where we see furniture that maybe, or fixed casework that can't be moved. Maybe in some cases, a piece of lab equipment that couldn't be moved. And so you want to try to coordinate that stuff earlier in the process, but certainly this is a final chance, because if you model that maintenance clearance outward and particularly downward, and you run clash on it, the general contractor runs clash on it, they'll see that it hits a piece of furniture or a piece of lab equipment that you're not going to be able to work around. So maybe it can be moved, maybe it can't. That's a game you'll have to play with the team to decide, is it worth moving it? Is it possible to move it? It's not always that easy to do, but at least it's identified and you can work through that. Another one here on the top right is a panel board and showing the maintenance clearances there. That is often has not often been modeled from our experience. It's good to see that being more the norm and ensuring it's a little hard to see it there, but there's a maintenance clearance in very faint blue in this case to ensure we have code required clearances. Something that's extremely difficult to fix after the fact is that once a bunch of things are installed and you find you take a tape measure and you pull off the face of that panel board and you say you run into a piece of pipe that's at 26 inches away, something has to move. And then we have had that happen at our firm a few times where plumbing pipe, mechanical pipe had to be moved to meet the code required minimum clearances. Okay, so some more things. Again, more maintenance access, but this is a lot of it. As a commissioning agent, that's a big part of what we're out to do, is to ensure that the operations maintenance team can do their work. So I mentioned earlier that a great deal of things are modeled in the BIM process, but often smaller conduit is not, and understandably so. It's hard to be rigid with that kind of requirement to model, say, 1/2 inch conduit. But what we have seen is something similar, which I call the no-fly zone, where generally speaking, this electrical subcontractor is going to follow a path for bundled conduit. They're going to run this area. They'll run a bunch of conduit through, and so they don't model individual pieces of the conduit, but they do model like a section for which conduit will fly, and that has to be avoided. Hence the no-fly zone term is what we've heard. There may be some other terms for it, but that's helpful. So you see an example here. You can see the pull box there and having maintenance clearance to pull all the way down to ensure they can get back to that. Another really big one for us is fire smoke dampers, and ensuring that those can be gotten to. One, in a BIM model, you can look to see that they've actually included access panels. That should be modeled down to the floor for a fire damper to ensure you can get up to it, get to the access panel to even inspect or re-engage the fire damper. And then fire smoke damper actuators, which also have to be accessible, modeling clearance out and down for that as well. Again, not everything is going to be easy to maintain, but using the BIM process to figure out where you'll have your struggles or where you could improve them where it's not ideal. Again, it's much easier to do in the 3-dimensional virtual world than it is to do in real life once it's in the field. And I personally prefer to have as few fights on job sites as possible because it's not fun. It's just generally more difficult to get things fixed in the field than they are before it's built. Okay. Another big one for us is path to and from equipment, and BIM is just a much better way to do this than in 2 dimensions on a drawing, though that's certainly part of it. You want your design team to be thinking about that. How are we going to physically walk to and from and get things through openings around in mechanical rooms and whatnot. So looking at this in 3 dimensions is just extremely helpful. So how are we getting to and from and around inside mechanical rooms and to, from, and inside mechanical penthouses, for example. So you see some examples here where this penthouse walkway in the bottom left here is actually a clear path. You can see this light green here is structural steel for mechanical piping that's flying overhead, and the spacing on that structure is both on height and width is sufficient to allow an operations and maintenance person to walk through there, in this case with at least a dolly to load a small motor in and out through that pathway, and ideally traveling the full length of a penthouse would be ideal, without things in the way, by the way. So ideally we would not see like a condensate line that's run across the floor there. That would be modeled as well. And it's not terribly helpful if it crosses the walkway path. It's best to avoid that. Again, you can see that in the field or in the model and fix it easier than in the field. The top right here is a recent example for us where it actually lines up with this the snapshot from the plans where we had these 4 pumps kind of in a row here, and just to the plan north, you see that red box, which is identifying the area of this double door. And in 2 dimensions, it doesn't look terrible that you're walking into this mechanical room and you kind of run into these pumps. You think maybe you've got some space, but when we looked at this in 3 dimensions, we noticed you really don't have any room. You can't get between those pumps with a dolly. You'd have to navigate over or around them to get back to a bunch of mechanical equipment that you can't see the plan south there. And so in the middle of the BIM process, this was actually a good opportunity for that to be fixed. So this is the mechanical room door there. That's a double door, and they created a maintenance walkway simply by pushing the pumps, splitting it 2 and 2 by services, so hot water pumps and chill water pumps, and creating some space so that you could walk through there with a dolly and get a pump out or any piece of other equipment that's in this case, pretty dense mechanical and plumbing mechanical room. Okay. And then path to and from equipment. So there's roof areas and access paths, a similar principle here. You see another example here where what is in our case, a busy roof well, mechanical well with lab exhaust fans around, and then in this case, cold room condensing units there pushed back. And just as recently for us actually, where this was all coordinated to allow maintenance access, you see this, the black lines overhead are the refrigerant lines. All of those were sitting down near the ground in this 3 weeks ago, and have since been moved up so that this path walkway actually goes to view north and then view east to allow, again, a path for that to happen. Otherwise, the maintenance team would have been climbing over all of these refrigerant bundled lines. So they got it up in the air, push it back up against the wall, the appropriate hangers. All of that would have just been discussed and debated on site when it was too late. And so in this case, we actually had the cold room vendor all join that BIM fly-through call to talk through that. And they have since made the updates that you actually see right here. I should have gotten a before picture too. It would have been helpful, but you get the idea. And then I mentioned earlier, vertical and horizontal access paths to the overhead equipment. And so I wanted to show a good example of that being modeled down to the floor here. So the yellow is the maintenance box or the maintenance path all the way up to terminal, in this case, terminal units with reheat. So that, this is in a corridor. So there's a clear path. For the most part, you see some clash with a wall, but there is a path, and we worked through that in this case. But there'll be plenty of times where that's just not true. You can't get every terminal unit or every lab supplier valve, whatever it may be, directly in a corridor, and so you'll have to work around things below. And you just try to avoid as much of that as possible. If it's movable furniture, if you clash it and you look at it and the contractor says, yes, but that's movable, that's FF&E, we'll be able to get it out of the way. Maybe it's no problem. If it's fixed casework with a sink, or we had one recently where it was an access panel to get to a terminal unit, but it was directly above a vending machine hutch. So you couldn't get above, you wouldn't be able to get above that to get back to it. So relocating the access panel is what was undertaken there. So pretty simple steps can be taken when it's still in the fly-through process. So just a few slides left. So what are we doing? What's the value to the owners? I mentioned earlier that it's not necessarily a ton of additional involvement beyond what we were already doing in our scope. So it gives us the opportunity to be represented in what I consider a pretty critical part of the process. When the subs are coordinating, they're making decisions on who will go where, and they're usually doing that. To be fair, they're usually doing that to avoid clashing. So somebody has to move. If fire protection line runs into ductwork, someone's going to have to move, and the winner is going to be whoever is the loudest or whoever has to do a certain thing by code. And so having an objective third party in that, like the commissioning agent, can be valuable to remind them, well, maybe we need to think through this a bit more. What are the impacts going to be to maintenance personnel if we do it a certain way? And you kind of make that known that so-and-so, whichever discipline is going to be the winner every time, knowing it's not that simple, and providing that input is important. And just having that O&M perspective is important as well. It's not just we got to get this finished. We can't produce shots until the BIM model's finished by floor. Not to slow the process down, but to make sure we bring that O&M perspective to the table. Ideally, even have them directly involved. But if not, the commissioning agent should be a fair stand-in, as you saw for the things we were just talking about. And then, again, discovering issues before they're installed really mitigates the costs. It's a cost avoidance thing, so it might be hard to identify and track for the owner's sake. But I'm sure certainly more sophisticated owners will understand that if we're participating in this BIM process and we found something that was going to be a problem in the field, and we remove that problem, even if it's not a cost to them, it certainly could be, as you see in the next point, it could be a scheduling impact. Moving things after the fact, because we visited, say once every month or once every couple of weeks, something could be installed that has become very difficult to move simply because we noticed it's a problem in the field. And we push that forward, we look at it in the BIM model, and we can avoid some of those problems. And then lastly, less finger pointing is always good. People are much more, I found earlier on in projects, tend to be more collaborative, more excited to get after it and work together positively. And so it's not built yet. So when you're doing it and having those discussions and debates in the model via fly-throughs, there's less finger pointing later because you've avoided some of the ugly things that can happen when you find those big problems during construction. So reducing those in the midst of construction, pushing them forward, I just generally found you get more positive feedback. And then getting the operations and maintenance personnel involved in this, at least to a point, as much as possible. But we know they're busy, that maybe if nothing else, they can only participate in the major mechanical, electrical, plumbing spaces. Well, that provides a method of engagement for them and a bit of an ownership and empowerment. And from personal experience, I think that's O&M people really appreciate that. I think generally, they're not listened to very much by anybody, particularly those that aren't in leadership that are, turning the wrenches, doing the work. Probably don't feel like they have much ownership in these buildings. They're just handed them and they have to go figure it out. And getting them involved in this process, in addition to the overall commissioning process, I think is extremely beneficial, provides a lot of good opportunities. Can be good for business, can be just good for building relationships that'll be beneficial in the future. And to be honest, it might even result in less callbacks to you as the commissioning agent if you've engaged them as much as possible in construction for our part. Okay, so that is the meat of it. I do see, Sam, we've got some questions coming in, and I want to make sure we have time. So I think we have plenty of time to start taking those.
Okay. Perfect. Thank you so much, Darren, for the presentation. Let's jump into the questions we have. So first one up, are these pre-construction BIM walkthroughs facilitated by the commissioning agent or by the GC for general contractor for the CxA? If the CxA is facilitating it, would they need to get access to the Revit file?
That's a fair question. So typically we are participating in these as they are coordinated and facilitated by the general contractor or construction manager. They are typically owning the construction phase model. We do look at them in design phase as well to some extent, and those are owned by the architect. So the preference would be that we are not facilitating them. We might be asking that they occur. That's usually what we're seeing happen, is we'll coordinate with our clients to suggest that they happen with an audience, not just the subs and their BIM leads. But yeah, so it's pretty simple. When they're facilitating it, they would lead the fly through, though we do also often ask for an ability to access the BIM model to remote fly through it. So several of these snapshots you see today, I caught from access to a particular couple sets of BIM models, so that I could give you those snapshots for today. And it's just nice to have. You don't have the ability to edit, but you really, again, you can learn a lot when you have those fly-throughs. But yeah, to answer the question directly, general contractor facilitates, we would participate and encourage them to occur.
Okay, a few questions on software Revit. Someone's asking, is software required in order to engage you and navigate the model?
Again, it's not necessarily the case. If you are content with just participating in these fly-throughs that we're suggesting, usually the person that's running that has the software. It's a general contractor, somebody who's in charge or a big part of the BIM process. So not necessarily. If you want the ability to fly through yourself separately, take your own time, look at issues on the go when you have time, then you probably do. So, but most of these platforms that are out there for BIM have view-only options where you're not actually putting in something that you could model with. It's not a full-blown Revit system. So it's really probably just a viewer. The one I was flying in the other day to help finish off this slide deck is a viewer only. So I can see everything. I can click and see what it is. I can tell if it's a pump, or I can even tell who the basis of design manufacturer is of a like a PRV, for example. But I can't do anything. I can't change anything. So it's just view only.
Okay. Another attendee was asking, and I'm assuming the answer is no here, is a CxA required to make models? Is he required to know how to create models and perform drawings, or is this all done by the designer originally?
Right. Commissioning agent, if we are truly, as we want to be, third-party independent commissioning agent, we are not creating BIM models. No, we're not creating them. We don't own them. We don't even necessarily again, need the software to even look at them. You could just do that with the contractor. So the short answer to that should be no. It resides with the architect engineer during design, and typically that is migrated over to either directly the files, or a separate undertaking is done for the construction team and their subs, who then own their own construction phase model.
Okay. Another person's asking about training to just navigate the Revit software. Is there anything out there, or is it necessary, or is it just with the viewer, it's just kind of simple?
Yeah, no, it's to be honest, it's not always that simple. All of them are a little different. You can get the hang of it, but they're usually it's specific to each vendor, each software provider. So there's some how-tos typically on their websites that I'd recommend you use, especially if you don't just have time to mess around and figure it out for yourself. Yeah, use their how-tos, follow some of their tutorial videos, and from there it tends to be pretty easy. And again, don't feel like you have to do that. It's if the client's not asking you to do that piece, I wouldn't suggest you have to. If you need something to do at night and are bored, you could do it for fun, but don't feel like it's an obligation. The main thing I'm suggesting here is that participating in the BIM process can be done simply by participating in a handful of meetings to convey what we think are important aspects of operations and maintenance and longevity. And that can be done without actually ever opening a BIM tool on your own machine.
Another attendee is wondering, what liabilities does the commissioning provider take on by being involved with the review process?
That is the question that is almost always the most relevant in this, I think. Well, really, in all things commissioning, is what authority do we have? In truth, we don't really have authority, and so what we aren't positioned to do as a commissioning agent is to direct work, and that includes in the BIM model. So where we may say we see a problem with access, right? I showed you several examples, and I think I've told you one where the pumps were moved so that allowed maintenance access, and we encouraged that. We didn't direct that, and I would suggest you shouldn't position yourself to direct that. You can advocate for it, but at the end of the day, you need the owner to say it's important to them, the contractor to say it can be made to happen, the design team to sign off on it, because really in the end, they're probably getting the RFI that facilitates that happening formally. And that's how it should go. You can provide your consultation and feedback, and I wouldn't say hedge is the right word. I'm not suggesting you hedge and don't provide your feedback and insight. Just know that you don't have the authority, and you shouldn't take on the risk of trying to create the authority and dictating anything to happen in the BIM models.
So another attendee is wondering, do you often find that one or two elements haven't made it into the model, say furniture, special systems, that impact the coordination later on?
Usually the big things, it is just our experience, so I can't speak to all modeling undertakings, but usually the big things make it. Fixed casework, fixed in place furniture, are almost always in there. BIM has become clean enough where manufacturers of even furniture have components in their libraries, and these contractors can drop them in there. It's usually the small things that just cannot get coordinated. And even if they are, I mean, they see it quite a bit where we all agree what's going to get modeled for conduit, what size, how it's going to be ganged together, small plumbing, piping, like lab gases and whatnot. And in the end, there's some deviation in the field. And when it's a crowded overhead space, it doesn't take much, an inch here or there. It makes the difference in whether pipes touch each other, dissimilar metals get in contact. You get hangers bumping into the ceiling grid. And those are just things you can't get around. You can't model. You can't expect the model to avoid all issues of coordination. But my experience is that the smallest things, the things that are either not modeled at all or are modeled in bundles, tend to be the things that cause the coordination grief. I think one of the slides I had showed a picture of a project that was modeled, but there were lab gas piping. There was lab gas piping run directly underneath some supplier valves that ended up being required to be moved, and were not intended to be there in the model. But that's where they ended up. These things happen in construction. So the idea is to avoid as much of that as possible in the BIM process as we.
So for the modeling, does it, in your experience, does it have the ability to track changes so the contractor can work off the designer's model and then update it as necessary to reflect as-built conditions?
I mean, I believe the answer to this is yes. So I won't pretend that I'm an expert in BIM, the BIM model process itself, where the GCs that own it, how their systems track those changes. I assume the answer to that is yes. I know there can be hiccups in the handoff between the design team and the construction team and those models. And then sometimes that has to be worked through. But I was actually looking at it earlier with that one with the roofing example, where we were looking at maintenance access in that roof well, where I'm not sure I could get back to easily get back to the old version of the model, where we did have refrigerant piping run along the roof line of the mechanical roof well, or not, which would have been nice. And maybe I can, maybe I can't. So I'd have to talk to GCs in particular about some of those nuances, I think.
Okay, thanks, Darren. So last call for questions. If anyone else has one they'd like to submit to the Q&A button. Final question I have lined up here is, do you document the BIM process in your reports? And if yes, what is an effective strategy?
Right. No, that's a good one, because I do think we should have some means of documenting this. Ideally, we'd have the general contractor document the meetings with a set of meeting minutes, and ideally some graphical representations. And that's typically where we go with it. It's not always that easy. They don't always necessarily do that. So I'd always suggest you keep your own notes, and we even keep them as field reports. In the tool that we use CxAlloy at Epsten Group, but we use meetings, the meetings function for that, and we document the input that we provided, what floor it was. It's usually pretty high level. We're not creating an exhaustive list, but it's something you can go back to for record if you needed to. That makes it clear, one, that we would participated. We conveyed some items of importance and what those might have been, and then yes, we would definitely put any of those meetings that we put a field report together, or a commissioning meeting file together, we would put in our commissioning report at the end of the project.
Okay, thank you, Darren. That is all of the questions I have for today. Clearly a lot of curiosity and interest in this topic. So I appreciate you coming on today and walking us through this. Yeah,
of course. Yeah, so we have a couple of minutes left. I'll just leave the group with, if you aren't doing this, don't be afraid to do it. It's not rocket science. It's the same types of things we're looking at when we're in the field. Given the feedback we got in the poll question, I think you could say today it's a differentiator if you offer it. And I don't think it's going to break the bank on the projects where BIM is really being leveraged. So it's something to consider. And don't be afraid of something a little bit different. Positive benefits can come from it from our experience.
Okay, thank you so much again, Darren. So we have another webinar coming up next month, October 13th, same time. Raj Sethi is going to come on with his colleague Jeffrey from Sethi & Associates. They're going to talk about a large Southern School District project and AIQ focused and driven commissioning tests. So we hope to see you there. Also, please save the date for CX Energy next year. Call for abstracts are open. We're still missing your abstract probably, or if you've submitted it, that's great. Wonderful. Thank you so much. Please enjoy the rest of your Thursday and have a good day. Bye all.